What feels incremental now will look like a breakpoint in 6 quarters. Welcome to AI on AI, where, yeah, we get nerdy and practical at the same time. Today, Ontology rule-guided self-evolving LLMs in data-scarce domains.
Right? The setup is simple. Use a few crisp domain rules to extract, validate, and re-inject knowledge the model already knows, instead of hoarding massive datasets.
From a business lens, that's huge. Compliance-heavy areas like healthcare or finance can't ship piles of sensitive data, but they can ship rules and concept hierarchies.
Technically, we probe subclass and synonym relations, then score each triple with a perplexity-based confirm value, which is basically good input, good output quantified.
And we apply two rules. Synonym implies subclass and subclass transitivity to build tiny reasoning chains. It's like snapping Lego bricks to fix missing rungs in a taxonomy.
Then we inject those gap facts via self-distilled fine-tuning. Implicit hints beat rigid templates because they feel more like natural answers than exam drills.
I'll be contrarian, ontologies can ossify. If a domain evolves weakly, rules might lag behind, and agents plus retrieval might adapt faster than baked-in hierarchies.
Sure, but selective rule injection targets blind spots without flooding the model. Think measure twice, cut once instead of open the fire hose and hope.
Okay, let's hit a use case. Medical QA systems answering exam-style questions and triage prompts without touching protected records.
Exactly, we extract the model's implicit hierarchy for cell, symptom, treatment, find missing subclass links, and re-inject just those gaps.
Strategically, this trims time to value. Parameter-efficient tuning on curated rules is cheaper and safer than bulk data hunts.
The confirm value gate is the bouncer at the club. No low confidence or contradictory triples get in, reducing hallucination drift.
In a finance taxonomy, it's like reconciling equity, synonyms, and subclassing instruments. Rules iron out naming chaos before downstream risk analysis.
Humor break ontologies are like closets. If you don't sort them, you'll spend mornings looking for your other shoe.
But retrieval-augmented systems can grab fresh docs. Rules won't cover breaking events or outlier edge cases near real time.
True, yet rules are seatbelts. Retrieval is the windshield. Use both so you don't fly through the dashboard during distribution shifts.
Recent developments, larger context windows, lighter fine-tuning stacks, and fresh safety guidance, all making small signals usable and auditable.
And speaking of safety, we checked adversarial prompts and jailbreak suffixes. Implicit injection tends to keep guardrails intact more than template-heavy Q and A.
Business takeaway: fewer moving parts mean easier audits. Fail fast, learn faster, but keep the paper trail of rules, prompts, and thresholds.
On thresholds, we sweep confirm value cutoffs to pick gap triples. The sweet spot balances novelty and factuality, avoiding catastrophic forgetting.
It's like debugging spaghetti code in the dark. A couple consistent rules give you the flashlight and a quick map.
In clinical knowledge, synonyms matter. Myocyte versus muscle cell. Bridging synonyms to subclasses avoids duplicated, conflicting concept trees.
I'll push back: synonymy in practice can be fuzzy. Context shifts and strict equivalence may fail for rare cases or regional terminology.
Fair, so we triangulate, only keep triples that form closed reasoning triangles, reducing the odds of reinforcing a wrong belief.
Let's do another example. Manufacturing fault taxonomies where subclasses mechanical failure and synonyms align maintenance logs.
Injecting those chain hints improves incident explanation systems that summarize sensor alerts and suggest next steps.
Also useful in customer support, rule-guided concept trees make agents less likely to bounce users between misnamed categories.
Process-wise, we start with layer-by-layer ontology extraction, score, filter, extrapolate with rules, then fine-tune on self-distilled answers.
The implicit approach attaches the reasoning chain as a hint. It's like whispering the proof outlined to the solver.
Explicit chains alone can feel like drilling. Hints nudge the model without locking it into rigid formats.
Agents could orchestrate this, run an audit tool, flag contradictions, then schedule micro updates as the domain shifts.
Yep, agentic loops plus rules equal continuous alignment. Think closed-loop quality control for model knowledge.
Quick humor. If your taxonomy feels like a junk drawer, you probably need rules, not just more drawers.
For leaders, this is a governance win. Rules are portable, auditable, and domain experts already trust them.
Budget-wise, small curated signals beat giant unlabeled corpora. You reduce noise and lower integration risks.
And the math isn't scary. Perplexity deltas tell you if true beats false for a relation across paraphrased prompts.
We avoid raw one-shot assertions. Multiple paraphrases debias the check, like asking the question 5 different ways.
We saw consistent gains on medical QA while keeping general benchmarks steady. The model doesn't forget how to do trivia.
Keep an eye on recency. Rules should be versioned and rotated or you'll encode last year's truths.
Future playbook hybrid stacks, rule-guided self-evolution, retrieval for freshness, agents for orchestration, and lightweight fine-tuning for precision.
Predictions. Models will ship with built-in ontology auditors, score gaps, and patch themselves nightly under governance policies.
And domains with scarce data will lean on rules as supervision, turning expert knowledge into a compact training signal.
Strategy tips start with your top 10 concepts, go 3 layers deep, and prioritize gaps that touch revenue or risk.
Technically automate paraphrase prompts and thresholds, log confirm values, and keep reversible updates for rollbacks.
It's like gardening, prune, graft, water. Small, steady care beats a once-a-year overhaul.
And remember, models aren't oracles. They're systems, give them structure, and they'll give you reliability.
I'll concede rules first, agents second, retrieval third. Blend them based on volatility.
The North Star is trustable competence, small signals, strong checks, continuous improvement.
That's our show, rules, gaps, and self-evolving models. Build carefully, audit often, and keep your taxonomy tidy. Stay with us for a concise summary of the highlights.
Narrated by the AI voice of Shri. The team is using ontology rules to help large language models adapt to data-sensitive domains like healthcare. The central question is whether a small set of expert rules can improve models without large domain datasets. Ontology means a structured map of concepts, their relationships, and rules within a specific field. A subclass relationship means one concept is a more specific type of another concept. A synonym relationship means 2 different terms refer to the same concept. 2 simple rules guide reasoning. Synonyms inherit parent classes, and subclasses of subclasses are also subclasses of the top class. The method extracts a tree of domain concepts and relationships that the model already knows. A confidence score called confirm value checks how strongly the model supports each relationship. Perplexity means how uncertain a model feels when predicting text, where lower values show more confidence. Confirmed relationships must pass a learned threshold across multiple prompts to reduce hallucinations. Reliable relationships are selected by finding 3-way triangles where 2 subclass links and 1 synonym link support each other. New subclass links are extrapolated from reliable chains to fill missing knowledge. Gap triples are credible facts with low confidence that the model has not fully learned. These gap triples are injected through self or distilled fine-tuning using explicit chains and concept-centric questions. Implicit and mixed injection produce stronger gains than rigid, explicit question templates. On 3 medical question answering benchmarks, accuracy improved by roughly 3% over the base model. A medical model already tuned on biomedical data gained about 4% more accuracy on average. General reasoning and safety stayed stable, and some tests showed small improvements. A case study showed the model correctly excluded the thymus when reasoning about reticular fibers in connective tissue. Experts highlight quality over quantity, using rules to add knowledge that fits the model structure. Challenges include setting good thresholds, avoiding noisy injections, and controlling catastrophic forgetting. Open questions include how many rules are needed and how to balance coverage with stability. This approach could help models evolve in finance and other protected domains without massive new data. Save someone a month of trial and error. Send them this conversation.